Welcome to this training module on PowerChute Network Shutdown software for VMware vSan. This training presentation explains how PowerChute Network Shutdown software works in conjunction with your APC UPS to protect your physical and virtual IT infrastructure from adverse power events. The next 20 minutes is structured as follows. For those of you not familiar with PowerChute, this module first provides an introduction to the software's capabilities before providing a high-level overview of how PowerChute works. We will then discuss the benefits of deploying PowerChute Network Shutdown in a VMware vSan environment, including the range of options available. Following this, a technical demo will show you how to configure PowerChute to support a vSan cluster before showcasing PowerChute Network Shutdown, protecting your vSan architecture during a power outage. At the end of this module, you will know how the software works, how to deploy PowerChute to protect your VMware environment, and understand PowerChute's flexibility, ease of integration, and configuration for vSan. PowerChute Network Shutdown works in conjunction with the APC UPS Network Management Card to protect your physical and virtual IT infrastructure from adverse power events. The software is widely deployed in server rooms, data centers, branch offices, network closets, and distributed networks to protect IT equipment during a power outage, minimizing time to recovery. Single, redundant, parallel, and advanced UPS configurations are supported. The first diagram shows a standard single UPS with a network management card inserted in the smart slot protecting 3 servers, each with a PowerChute Network Shutdown agent installed. The UPS Network Management Card sends status updates every 25 seconds to each PowerChute agent or immediately if there is a state change, such as the UPS switching to battery power. PowerChute will then initiate actions such as running a command file or starting a shutdown sequence depending on the nature of the UPS event and how PowerChute is configured. As mentioned previously, PowerChute Network Shutdown supports the following UPS configurations. Single UPS configuration. A single UPS protecting 1 or more servers. Redundant UPS configuration. Up to 4 UPSs configured in a redundant UPS configuration supporting 1 or more servers. Each UPS has the capacity to supply power to the load on its own. The first UPS provides all the power for the load. The additional UPSs act as a reserve. Parallel UPS configuration. PowerChute Network Shutdown recognizes that the UPSs are set up in a parallel configuration and will monitor the changing load on the UPSs to manage how UPS events are aggregated depending on the level of redundancy in the system at any given time. Advanced UPS configuration. The advanced UPS configuration enables a single PowerChute Network Shutdown agent to monitor multiple UPS setups and initiate graceful shutdown based on different redundancy levels. Each UPS setup can be a single UPS or a UPS group of 2 or more UPSs. PowerChute Network Shutdown is certified VMware ready for vSphere and provides extensive graceful shutdown capabilities in a vSan cluster. The VM prioritization feature allows you to control the order that VMs are migrated, shut down, and powered on. PowerChute can issue commands to shut down and power on vApps. vApps can now be prioritized also. Depending on the number of hosts impacted by an adverse power event, PowerChute will place hosts into maintenance mode using the correct vSan data evacuation mode to protect your VMs. In an advanced UPS configuration, PowerChute can be configured to use the fault tolerance threshold set for the cluster to keep VMs running by using the Ensure Accessibility vSan Data Evacuation Mode flag. This occurs when only some of the hosts in the cluster are impacted by a power event. PowerChute supports vSan stretch clusters. PowerChute will gracefully shut down VMware hosts after they are placed into maintenance mode. PowerChute can detect if vSan or server is running on a virtual machine in the vSan cluster and gracefully shut it down. The intuitive, step-by-step setup wizard makes it quick and straightforward to set up APC power protection with your vSan cluster. Our focus on usability means features such as the graphical representation of your virtual cluster environment and UPS setup has made configuration as seamless as possible by providing an intuitive view of your UPS and host configuration on a single screen. Lastly, the vSphere plugin option integrates PowerChute with vCenter Server for ease of management enabling PowerChute monitoring for the vSphere client. Plugin options are available for either the vSphere desktop client or web client. We are now going to move on to a technical demonstration of how you can configure PowerChute in a VMware vSan environment. Before we launch the PowerChute setup, here is an overview of the VMware environment you need to protect. A single UPS is powering a vSan cluster with 3 ESXi hosts and a separate physical machine with PowerChute installed. PowerChute Network Shutdown version 4.3 for VMware is available for download free of charge on apc.com. Choose Products and Services. Select UPS Management. Choose PowerChute Network Shutdown. Click Download. Choose Windows Installer. Select to download. Extract the installer once the download completes. Double-click Extracted Setup x64.exe to start the installation. The PowerChute Network Shutdown Setup window opens. Click the Next button. Click the I agree button. Select the Enable VMware Support Radio button. Click the Next button. Click OK. Click the Next button. Click the Install button. The Configure Firewall window opens. Click the Yes button to configure the firewall and continue with the installation. Click the Finish button to launch the PowerChute configuration wizard. Click Next on the welcome screen. Select IPv4 or IPv6 and click Next. Choose Host Managed by vCenter Server. Click Next. Enter hostname or IP address for the vCenter server. Enter vCenter server username. Enter vCenter password. We enable this option since vCenter Server Appliance is deployed on the vSan cluster. Click Next. Choose Single UPS Configuration and click Next. Enter PowerChute username. Enter PowerChute password. Enter authentication phrase. This must match value on the network management card. Click Next. Enter network management card IP address. Click Next. Review settings and click Apply. Click Next once PowerChute is successfully registered with the management card. PowerChute connects to vCenter server to retrieve information from the data center. Data center, cluster, and host information is retrieved. To protect the hosts, select them and drag to the right-hand side. Note that the host running the vCenter server appliance is marked with an icon to identify it. Switching to vCenter server, we can see how PowerChute displays the host information in a similar tree view to vSphere. Click Next once all vSan hosts have been added for protection. If your UPS supports outlet groups, this page is displayed. Select the outlet group that is supplying power to the ESXi host machines. Click Apply. Click Next once PowerChute is registered with the outlet group. The Virtualization Settings page allows you to define the shutdown behavior when an adverse power event occurs. PowerChute will gracefully shut down VMs and vApps. Note, we will not enable VM migration in this demo since the entire vSAN cluster will be shut down. Select VM vApp Startup to have PowerChute automatically power on VMs and vApps that were shut down when normal power is restored. If a vSAN sync operation is in progress when a power event occurs, PowerChute can be configured to allow time for it to complete before shutting down hosts. In a vSAN environment, it is recommended to delay maintenance mode until after all VMs have been powered off. The timeout here is the time allowed for each host in the vSAN cluster to enter maintenance mode using the appropriate vSAN evacuation mode. Hosts are placed into maintenance mode sequentially to avoid multiple hosts entering maintenance mode at the same time. By default, the vCenter server VM is treated as a special VM and shut down after other VMs. Set the required time for vCenter server to shut down gracefully. A plugin option is available for the vSphere client. Click Next. Review settings and click Next to continue. Note, these values can be modified later in the main UI if needed. Select Turn off the UPS to prevent the battery from draining once all VMs and hosts are off. This helps to prolong battery life. Click Next. Click Finish to complete the setup. Choose Configure Events to define when PowerChute should trigger a shutdown sequence. To shut down if a power outage occurs, click the gear icon for the UPS on battery event. Select the checkbox Enable Shutdown. Set a delay. This is the amount of time the UPS is running on battery power before the shutdown sequence is initiated. Click Apply. Select Shutdown Settings to configure a shutdown command file. Choose Run Command. Enter the path to a command file which can be executed during the shutdown sequence. Select Execute Command File after host shutdown to wait until ESXi hosts are powered off before running the command file. From version 4.3, you can also use Ssh Actions to execute commands on remote systems via SSH. Multiple SSH actions can be added using the Add Action button. SSH credentials are encrypted and securely stored in PowerChute. Define when the SSH action should be executed. Choose Virtualization settings to refine shutdown durations as needed for your environment. Here, we increase the timeout to 30 seconds. Click Apply to save these changes. Select VM prioritization to enable granular control over when VMs are shut down and powered on. Select Enable VM prioritization. In this setup, there is an external platform services controller, VM. This needs to be shut down after the VCSA VM and started before it. This can be achieved by adding the Platform Services Controller, VM, to a higher priority group than the VCSA VM. To add VMs, select them on the left and drag to a priority group on the right-hand side. Specify shutdown durations for each priority group. Click Apply to save your changes. Switching over to vSphere Client, we can see the VMs listed are the same as those shown in the PowerChute UI. We will trigger a power outage on the UPS protecting the vSan cluster to illustrate the shutdown sequence. For the purposes of the demo, we have set a short delay for the on-battery shutdown action. PowerChute detects that the UPS has switched to battery power. After the configured delay has elapsed, PowerChute starts the shutdown sequence by shutting down VMs. VMs are shut down by their priority group assignments. Group 2 VMs are shut down first. Then Group 1 VMs are shut down. Then low priority group VMs. Next, the vCenter server VM is shut down since it belongs to the medium group. Note, since vCenter server is being shut down, we switch over to the ESXi host web UI to show it being shut down. Lastly, the Platform Services Controller VM is shut down. Once all VMs have been shut down, PowerChute places each host into maintenance mode sequentially. The maintenance mode duration is used as the interval between each host. When the host has entered maintenance mode, it is then gracefully shut down. The maintenance mode and shutdown commands are sent to each remaining host. Finally, the machine running PowerChute is gracefully shut down. You have now reached the end of this e-learning module. To learn more, you can go to the product pages on apc.com to access online materials, including application notes and user guides. You can also download the software via Products and Services link on the APC homepage.